Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. And now you can recall that in the last couple of lectures we have talked about different measures of variation. And before that we had talked about different measures of central tendency. Now, if you try to look at the broad question which we are trying to answer here is the analysis of the data. And this analysis of the data is being done based on different features of the data. So we had earlier talked about the measure of central tendency. Then we have discussed different measures of variation. But both these features, they are related to the data set only. And essentially, we are more interested in real life when we are trying to compare two data sets. So, when we are trying to compare two data set and if we consider only one aspect like a central tendency or the variation, do you think that is it really going to give us the correct outcome? Actually, both have to be compared. Now, when we are trying to aim to compare the data set with respect to the central tendency and variation both, suppose if we have a situation where I have got two data set and the mean of data set 1 is more than mean of data set 2, and suppose their variability are just opposite, that the variability of data set 1 is smaller than the variability of data set 2. Or there can be different situations where we would like to take into account the information about the mean and the variation simultaneously. So, how to get it done? For example, I can give you one example. Many times you hear that somebody is working in US and the salary is about say 2 lakhs of rupees a month. Now, in case if you try to compare the salary of 2 lakh rupees a month in India, then it's a reasonably a good amount. And if you are staying in a metro city, possibly you can have a good life. And if you are staying in some non-metro city, this rupees 2 lakhs a month is a handsome salary to have a very good life. But usually you will see that with 2 lakhs rupees a month, when you try to convert it into say US dollar, that may come around $2,000 to $2,100 approximately. So, if you try to answer the question that whether with 2 lakh rupees a month in a city like say Kanpur, where I am located, and with say $2,000 in US in say some reasonable city, can you have the same standards of life? Think about it. In my experience, no. For example, in a city like Kanpur, if somebody is getting say a salary of this 1 lakh rupees a month, the person can have a reasonable life. But possibly that standard may not be possible to attain in US cities if somebody is trying to earn $1,000 or say $1,100. So, now the question is how to compare it. For example, many times in the campus placement, you hear the news that the package of some students is several lakhs, several crores. But if you try to see, most of these packages are in some European city, good country, or say European, say good city, or say in American countries, American cities. where the income and the expenditure, they are in terms of euro or say dollar, which are very different than our expenses in Indian rupees. So if you try to compare the standard of living, what they will have with that package, or what type of life they can have with that salary, that is not comparable. Actually, what we try to see, we try to compare the euro or dollar into Indian rupees, and then we try to think that as if I am getting this salary in India, then the type of life will I have here in India, possibly the same type of life that person will have in that country, which is usually not correct. So the question here is how to get logical conclusion in such situations. In such situations, if you want to compare the values or if you want to compare the data set, what we need is a combination of measure of variability and central tendency both. So with this objective, we are going to introduce here the concept of coefficient of variation. Then there is one more aspect. When we are trying to consider our data, so when we are trying to have the central tendency as well as the measure of variation, there can be different things. There can be median, there can be interquartile range, there can be quartile deviation, there can be minimum, there can be maximum, etc. And what you want to compare the data set in totality. That means you want to implement more than one tools at the same time. How to get it done? So for that, in our software, actually we have a command here, summary, which gives us an idea about the different values at the same time. So we will discuss about this summary command in this lecture. So let us begin our lecture and try to understand about the coefficient of variation and summary command, and we will try to see how they can be implemented in the R software also. So let us begin our lecture. So now, first topic I would try to take here is the coefficient of variation. So now the coefficient of variation actually measures the variability of a data set without reference to the scale or units of the data. And this coefficient of variation is also called as CV. C means coefficient or V means variation. And what does this mean? I will try to just show you. And it is useful when we are trying to compare the result from two different surveys or two different tests in which the values are collected on different scales. For example, I just give you an idea where the salaries have been collected in terms of Indian rupees and in terms of US dollars or say euros, right? So now how to compare these values? Suppose there are two data sets and we compute their sample means and standard errors. So suppose x1 bar and x2 bar, they are the sample means of the two data sets, and say S1 and S2, they are the standard errors of these two data sets. Now the issue we want to address here is how to compare these two data sets, right? So in order to compare such databases, we have a concept of coefficient of variation, and we try to compute the standard error or say standard deviation, and we try to compute the arithmetic mean of the sample data. And based on that, we define the sample based coefficient of variation, which is going to measure the variation using the arithmetic mean and the standard deviation as CV is equal to S upon X bar. So you know that standard deviation is always positive, but X bar can be negative or can be positive, or it can be 0 also. So it is important to note that the CV is properly defined only when X bar is equal to 0. Right, because if some data is negative and its arithmetic mean is coming out to be negative, so actually we are more concerned here about the magnitude, not with the sign of the values, like as temperature is minus 20 degree, right. So in case if you have two data sets you want to compare, then we can compute the coefficient of variation of both the data sets, and the data set with a higher value of coefficient of variation is said to be more variable than the other, right? This is the rule. Now, we consider an example here to understand that how this concept of coefficient of variation is helpful in understanding the behavior of the data. Suppose two different experimenters, they take a sample of data, and both the experimenters measure the heights of the students or the children of the same group in say centimeters and in meters. So, we have the group of same these children, say x1, x2 and say here some here xn students or say children, and their heights are measured in say meter as well as in centimeter. So, now the experimenter 1 measures the height of the children in say meters, and the value comes out to be x1 bar as a 1.5 meter, and the standard deviation comes out to be say S1 is equal to 0.3 meters. And the second experimenter measures the height of the same student in centimeters, and it comes out to be say x bar 2 as 150 centimeters, and standard deviation here as say S2 30 centimeters. Now, in this case, what do you say? Whose height is more or less, or what is the variation in the data? So, now we compare here their coefficient of variation. So, I compute the coefficient of variation from the data 1, which comes out to be 0.3 divided by 1.5, which comes out to be 0.2. And similarly, the coefficient of variation in the second set of data is CV2, which is 30 upon 150, which is equal to 0.2. So, if you try to see, although we have the reporting as if there are two different data sets, but they have the same characteristics. So, do you think that the both answers are the same, and how to report it correctly? Apparently, if you try to see this S1 is 0.3 and S2 is 30. So, S1 looks to be much lower than the value of S2, and similar is the case that the arithmetic mean of the first experimenter is 1.5, and whereas the arithmetic mean of the second experimenter is 150. So, it looks like that the average height or the value in the case of second experimenter is much higher. So, now how to take care of these values? So, in those cases we try to compute here the coefficient of variation, and you can see here the coefficient of variation in both the cases, they are coming out to be the same 0.2 and 0.2, right. So, that means that both the data sets have got the same variability and there is no variation between the two sets of data. So, this coefficient of variation actually helps in comparing the data sets on two completely different measurements. These variables are measured in different scales like as meter or centimeter, but the CV is dimensionless, because CV is the ratio of this standard deviation you can see here and mean. So, if you have the say observation are in say the centimeter, then standard deviation and mean both are going to be in centimeters. So, S upon x bar will become dimensionless, and so the comparison of this coefficient of variation from different data sets is possible. For example, if I say the rents of houses in a metro city and a village, they cannot be compared as such, right. And similarly, the rents of houses in say Mumbai in say Indian rupees and the rent of houses in say London, if you want to compare, then how to compare them? They have to compare with respect to the income or the salary. So, in such cases, this coefficient of variation concept helps, right. So, the decision making goes like this. The data set having a higher value of coefficient of variation is considered to have more variability, and the data set with lower value of CV is preferable. So, if we have two data sets and suppose we compute their coefficients of variation as say CV1 and CV2, then if CV1 is greater than CV2, then the data in CV1 is said to have more variability or say less concentration around mean than the data in say data set which was used to compute CV2, right. So, that is the idea. Now, we understand how we can compute the coefficient of variation in our software. So, there is no direct command to compute the coefficient of variation, but that can be computed without any problem, because in order to compute the coefficient of variation, you need to compute the standard error and the arithmetic mean. So the standard error can be computed by SD command and mean can be computed by mean command. So if I have got a data vector x which has all the observations, then I can compute the coefficient variation by the command SD of x divided by mean of x. Alternatively, if you want to use the command square root of variance of x in place of standard deviation, then that can also be used and divided by mean of x. In case if your data vector has some missing values indicated by capital N, capital A, and this data is stored in, say here, XNA data vector, then the R command to find the coefficient of variation will be simply the same, but what you have to be careful that the command for standard deviation and mean are to be used, which are used when the data is missing. So I use here SD of x and A with the option NA dot RM is equal to true divided by mean of x and A with NA dot RM is equal to true, right. Or alternatively, you can use the variance command and take its square root with the command, say VAR of x and A with NA dot RM is equal to true divided by mean command of x and A with NA dot RM is equal to true. Right. So here this is the definition for, say here, ungrouped data. Right. If you have a group data, then a similar definition can be developed without any problem. Now we have done so much between grouped and ungrouped data that it is not difficult for you to develop such a definition for the group data also, right. So now let me try to take here an example and try to show you how are you going to compute the coefficient of variation. So we consider here the same data set that we have used earlier couple of times, that there are 20 participants who have participated in a race and their time to complete the race has been recorded in seconds and the data has been obtained here, which is stored in a data vector here time, right. So if I want to know the coefficient of variation, then simply I have to write down here SD of time divided by mean of time, and you can see here this is 0.3. And similarly, if you want to use other alternative, that is square root of variance of time divided by mean of time, then also this is the same thing, and this is here the screenshot of the same operation, right. And similarly, if you try to consider the case of missing data, so suppose in the same data set I assume that the first two observations on the time they are missing as NA, so I report them here as NA and the data vector is now time dot NA, in which I have stored all this data. Now if you want to find out its coefficient of variation, so you have to use here the command here SD and within parenthesis time dot NA with NA dot RM equal to true, and then mean of time NA dot NA with NA dot RM equal to true, and this value comes out to be here 0.27. And similarly, if you want to use here the square root of variance command to compute the standard deviation or standard error, that can also be used with SQRT variance of time dot NA with NA dot RM equal to true, and the mean command will remain the same as mean of time dot NA with NA dot RM equal to true. And you can see here this is again the same value that you have obtained, and this is here the screenshot of the same operation, right. So first let me try to show you these things on the R software so that you can have the confidence that it is working, right. So you can see here this is here the time data set, so you can find out here SD of here time divided by mean of time. So you can see here this is here 0.300. And similarly, if you want to use here this square root of variance also, then also you can use it here and it will give you the same value here. And similarly, if you try to take here this data set time dot NA, and then this data is stored here, you can see here time dot NA, right. This is here like this. And now if you want to find out the coefficient of variation when this data is missing, you can use the command SD divided by mean when the data is missing, and it is coming out to be 0.27. And if you want to use the command here, say here this say square root of variance to compute the standard deviation, then it will come out to be here like this, right. You can see here this is the same value, right. So you can see here that's a very simple command and very simple concept, but very useful. Okay. Now I come to one more aspect. Whenever we are trying to deal with different data sets in data science, then we want essentially to compare them with respect to all sorts of properties like as central tendency, variation, etc. So ideally we should get all these things, say this individually, like as we can compare the minimum values of the two data set, maximum values of the two data sets, mean values of two data sets, first quartile, second quartile and third quartile of the two data sets and so on. So in the R, there is a command here, summary, which gives the outcome about this information like as minimum value, maximum value, mean value, first, second and third quartile at the same time. And for that the command here is, if you have the data vector here x, then if you use the command here summary SUMMARY of data vector x, then it will give you all these values for a given data set at the same time. So this actually helps a lot when you are trying to compare two or more than two data sets, so that you can view all this information at the same time for different data sets. For example, if I take here the same example where the time taken by 20 participants in completing a race has been recorded like this, and this data has been stored in the data vector time, then if I try to find out here the summary of time, then it will give me here the minimum value here, first quartile here, second quartile which is here median like this, then the arithmetic mean here like this, third quartile here like this, and the maximum value here like this. Right. So this is how you can compute these values at the same time, and they will give you an overview of the data. Later on you will see that by looking at these values you can derive different types of statistical properties, like whether the data is symmetric or is skewed. That we will see later on. We will discuss about these aspects, right. And this is here screenshot of the same thing, and now let me try to show you these things over in the R console. So you can see here we already have the data here time. So I will try to show you here, this is here summary of time. So you can see here this is coming out to be here like this. So you can see here, this is here the minimum value, then first quartile, then median 56.5, then arithmetic mean 56, then third quartile which is 68, and then maximum value which is 84, right. So this is how you can see that you will get here an overview of different pieces of information at the same time. And if you have more than two data sets, then you can just find the summary command for both the data sets. You can put them side by side and can compare different data sets. And this will also give you a very good presentation if these things can be converted into a graphic also. So now let me stop in this lecture. You can see that it was a very simple lecture where I have introduced you the concept of coefficient of variations and this summary. I have given you the concept and I have explained its utility. Now it's your turn. Please try to take one data set and try to make certain changes into it, and then try to compute the coefficient of variation in the original data set and in the changed data set. Try to execute the summary command on the original data set and in the changed data set. Try to take some extreme value and try to see that how the values are changing. The mean value will change a lot, but possibly the first quartile, second quartile, third quartile in the summary command outcome will not change that much. But how much is that much? That is what you have to understand based on the data values. And then try to take some bigger data sets and try to compare them with respect to coefficient of variation, and try to use the summary command. And with these things also, I would say that try to get some more information through the absolute mean deviation and variance, and try to compare with them with CV, that is the coefficient of variation, and see how the values are changing to give you a better idea about the information hidden inside the data set. So my request is that please try to take some data set and try to practice, and I will see you in the next lecture. Till then, goodbye.